Okay, so this is a bit of a rare beast. Hewlett-Packard 9830A calculator, computer, whatever you want to call it. Not something I expected I would ever acquire. Anyway, I've gone through, cleaned it all up, and I'm satisfied with the state of the machine. There are a couple of electrolytic capacitors I need to check, and I'll probably end up replacing all of them just for reliability's sake. But at any rate, the most important thing I want to do before I dare power this up is ensure that it can't cook itself. Thankfully, this iteration, this version of this machine, it includes crowbar circuits in the power supply. What that means is if the power supply outputs for any reason exceed a safe value, the crowbar circuit is designed to short it out. So at the very worst, you damage the power supply. You don't go smoking all of your logic. So you can see here, this guy here, this one here, and that there, and maybe even this one is, I didn't check yet. These are all SCRs, silicon controlled rectifiers, and their job is to work in concert with these little, you can't really see them, Zener diodes, and they sit across all of the output voltages, and they measure. And if the output voltage exceeds the threshold set by the Zener diode, it turns on the SCR. And what an SCR does is once it's turned on, it will remain essentially shorting the line to ground until the current is removed. So this will just dead kill the output until you turn it off or until the fuse blows, whichever, or maybe it goes into current limiting. Whatever it is, it saves your day. So what I've done, I want to test these. I want to actually see the crowbars work before I try this out. And you can actually activate them on board without hurting anything. All you need is a low current or current limited power supply. Adjustable current limitation is nice, and adjustable voltage. So where I'm at right now is I've got my leads clipped across the output bypass capacitor for the 5-volt power supply rail. Now, what this means is I go over to my power supply. I've set the current so it limits to maybe 300-400 milliamps. It's not very much. And now I'm watching the voltage. It's at 0 right now. And what I want to do is turn this up, and you see the voltage rise. You can see that very clearly. And it rises and rises as I go. And of course I get up to about 5. Okay, fine. Now watch what happens. I get up to about 5.5, a little more, and pop. You see it goes down to about 0.9, 0.8 volts or so. If you look over, there's the current limit that I set, 450 milliamps. So what's happened is that SCR, this device right here, is now turned on, and it is just shunting all of my current away from the power supply, and then basically forcing the voltage to drop down to a harmless level. Now what's interesting is, I go back here, if you watch, okay, I've got 450 milliamps of current. As I turn this down, that doesn't stop. That SCR is staying on until I get it down to a very low voltage. There it goes. So where was I? Half a volt. Okay, so that's how low I have to go in order to turn the SCR back off. So I can do this for all of the power supply rails here. All I've got to do is ensure that I've got my polarity correct and that my power supply will actually reach a voltage exceeding the thresholds that are set for these. So I've just done the 5-volt supply rail. There are others. We have -12, plus 19.5, and I think, let's see, plus 16. And there could be more, I'm not sure, but the point is, this little power supply only goes to 12 volts, so I can't test the others with it. I'm going to have to go over to the tech power supplies I've got over there. They go higher. And I'll be checking all of these crowbars, and as long as they short out my power supplies, then I'm satisfied that this thing is, it may not work properly on the first try, but I know it's going to self-protect. It's not going to blow the rest of the logic up and leave me crying and moaning for the rest of the week. Thanks for watching.